This is 1.2 on functions. We have a bunch of different graphs of some relations of x and y, and we're going to determine if they are a function and then look at what the domain and range are, and also evaluate at some given values of x. First one is a line, and if we apply the vertical line test, we will see that there's nowhere that we can draw a vertical line that's going to cross the graphed line more than once. So the answer to that first question is yes, this is a function. And every time you have the graph of a line or equation of a line, you can know for sure that it is a function. So now we want to look at domain and range. So the domain is all the values that x takes on. Okay, so if we consider that there are these arrows that are saying that the line continues to go to the left and to the right, it's not ever going to stop. It's unbounded to the left and to the right. So the domain is all real numbers, or negative infinity, positive infinity. If we look at range, right, those are the values that y takes on. And again, those arrows are saying that it's unbounded. And as x gets larger and larger, as x values go to positive infinity, the graph is going up. It's increasing. And so the y values are just going to get larger. So to the right, the graph is going up, going to positive infinity. And if we go to the left, as x values get smaller, we can see that the graph is going down. It's decreasing, so it's going to be unbounded in that way as well. So the range, the y values, negative infinity to positive infinity, are all real numbers. Let's look at the next one. It's a parabola, which is a quadratic. We actually have the equation for that as well. If we want to test it using the vertical line test, all right, we see that there's no place where it's going to cross more than once. So this is a function. And let's look at domain. Okay, so again, we got arrows here. So it's saying as we go to the right, all right, it's going to keep going down, all right, and it's going further to the right. So, and if we look on the other side, on the left, it doesn't look like there's any bound there as well, and the graph is going to keep going down, but it also is going to take on all values of x to the left. So the domain is all real numbers. What about the range? Range. All right, values that y takes on, so we kind of want to look up and down vertically. Okay, well right here, it looks like that's kind of the top point of the parabola. The graph doesn't go above that at all. That point is, x value is 2, the y value is 4. So all the other y values on that graph are going to be less than 4. Okay, so the range, it includes 4, all right, and all the other values are less than 4, so it's unbounded in the negative direction, and it goes up to and includes 4, so that's the range. Okay, so for this one, let's evaluate for a given value of x. Okay, let's evaluate for the value x of 2. All right, so that means we're just going to plug in a 2 where we have x show up in the equation or in the function. So if we evaluate that, we do the squaring first and then we do the negative. So negative 4 plus 4 times 2 is 8. So if we evaluate it 2, we get positive 4. And we can kind of double check that with the graph, because if we have this function that's evaluated at 2 and it equals 4, that means that the point 2, 4 should be on the graph. All right, which it is. It was actually that highest point, which is actually what we call the vertex. Okay, let's look at this one. This is actually called an ellipse, and if we test this, whether it's a function or not, we are going to see one vertical line crosses in 2 points. So this is not a function. We can still determine domain and range. Domain is going to be the x values. Okay, so we can see from left to right, it goes from -6 to 2, and those values are included. So -6 to -2. Range, all right, we can, oops, let me get that a little closer. All right, there's the top part of the graph. It doesn't extend above that, and there's the bottom part. Okay, so if we want to, we can identify what those points are. It's -4, 7 here, and then down below, that lowest point is -4, 1. So it's the y values that are going to give us the range. So the range goes from minimum value, and it's included, is 1, to a maximum value of 7. Oops, and we've got to make sure we include that, so we use the bracket. All right, we don't have an actual equation to use, but we can still evaluate at a given value of x. All right, let's evaluate at the value of x of -2. There we go, -2. Let's plug -2 in there. All right, well, we find -2, and we find the point that it goes with, and it corresponds to a y value of 4. Okay, so we evaluate at -2, and we get the function, or we get the y value of 4. Okay, so that means the point -2, 4 is on the graph of that equation. Okay, let's look at the next one. Now this next one is a cubic, so I'm just going to label that. All right, it's cubic because it's got an x cubed term in it. In fact, it's given to us as y equals x cubed. All right, and that's that's the shape of a cubic as well. If we do a vertical line test on this, we're going to see that there's no place that we can draw a vertical line that it's going to cross more than once. So this is a function. So yes to that question. So now if we want to look at domain, so we basically want to say, is it limited left to right? Can we find a leftmost spot or point, and can we find a rightmost point? And we really can't. So that means that we've got all real numbers for domain. And then range, we want to see if we can find a top point of the graph or a bottom point, and we really can't. It extends all the way up and all the way down, so all real numbers, right? -infinity to +infinity. All right, let's evaluate, and all right, it's going to be something cubed. All right, let's plug in a 3. All right, so if we plug that into the function that's given to us right there, y equals y cubed, take that 3 and cube it, and we get a value of 27. All right, we can't actually see that on the graph. Let's do a different one that we could see on the graph. Let's take f of, and let's plug in a -1. All right, so here we want to, because we're plugging in the -1, All right, well, I think about it in parentheses, but if we cube a negative, oops, that should be cubed. If we cube a negative, right, that ends up being a negative. So our result is -1. All right, so if we go to our graph, we can see that there's that point. -1, -1. Okay, let's look at this next one. This next one is what we call a piecewise function, where it's actually defined by several different equations. And we just want to identify at this point if it's a function or not. Okay, so we use our vertical line test. Okay, we've got to kind of do this several different places. All right, well, I don't think there's anywhere in this graph where we're going to cross more than once. So even here, you see that's an open point and a closed point. So it's only crossing right there. It's not really crossing the graph at that open point. All right, same thing here. It's crossing at that closed point, but not that open point. So we can say that, yes, this is a function. And let's look at what the domain is. Can we find a leftmost point or a rightmost point? Well, we can't, all right? It's continuing in both directions. So we have -infinity to +infinity. So range, range, we want to see, do we have a top point or a bottom point? Okay, right here, actually let me do this in this color. Here is the bottom point. All the other points on that graph are above that, and that's the point 0, 0. Okay, so the y value of that lowest point is 0. So that means that the range goes from and includes the value 0, and it includes all the values greater than 0. So it goes from 0, and it's unbounded, to +infinity. All right, so let's evaluate at a given value. Let's try f of 1. Okay, so if we plug in a 1, all right, we go where x is equal to 1. Actually, here, let me get rid of all this stuff that we've got on the graph so far, and I'm going to start from scratch as we evaluate. Okay, there we go, and let's get rid of that too. Okay, so let's go back, and I'm going to put my independent variable in x in red. Okay, so we find where x is equal to 1, and we find that point. Well, that is the point 1, 1. So that means that the function value when x is equal to 1 is 1. All right, so just note that this right here is not a point. Okay, so that's not going to give us a function value. All right, let's look at f of, plug in 2. All right, so if we find the point where x is equal to 2, okay, it's this point right here. And that point is, the x value is 2, and the y value corresponds to a 3. So that means the function value when x is equal to 2 is 3. All right, let's do one more. Oops. Let's look at f of 3. So you find the point where x is equal to 3. We go up from 3. Here's the point right there. Well, what's that point? It is the point 3, and it corresponds to the y value of 3. So the function value when x is equal to 3 is 3. Okay, let's look at this one. First, we want to determine if we have a function. So we use that vertical line test. All right. I don't think we're going to find anywhere where it's going to cross more than once, so it is a function. So let's look at domain. All right, looks like we have a leftmost point right here and a rightmost point right here. Okay, so this leftmost point is, we can label that as -4, -3. And the rightmost point is +3, -3. Okay, so the domain, we want to pick out those x values. So the domain goes from and includes -4, and goes up to and includes a +3. Looking at the range, okay, here is the topmost point right there, and that is the point 1, 2. And we have 2 bottommost point, and they actually are the same as the right and leftmost point. So this time we want to pick out the y value, right? Notice that it's the same on both of those. Okay, so the range goes from and includes -3 and goes up to and includes a +2. Okay, one more for us. All right, here, this is the Batman relation. We got to figure out if it's a function or not. So we put vertical lines in there. We see that, yeah, it's going to cross at more than one place multiple times. So Batman is not a function. All right, and so let's get rid of all of those vertical lines. All right, we can determine domain and range. Okay, so the leftmost point of the Batman function is right there. And to me that looks like that is the point -7, 0. And the rightmost point is right there, and that looks like that is the point 70. So our domain goes from -7 to +7, and it includes both those values. Range. All right, we've got, this is kind of tricky to see. But I think our top points are the top of his ears right there. Okay, and it's kind of hard to tell exactly what the x value is, but it looks like the y value is 3. So I think for both of those we can say the y value is equal to 3. And that's all that matters. We don't need to know the x value because we're just looking for the y value. And it looks like the lowest point is right here, and they're making it kind of hard for us to figure out what value that is. I'm going to say that it is about let's say 6 is y. Okay, so we're kind of estimating that, but I think that's close enough. So we can say that the range for the Batman graph, the range for the Batman graph goes from, it's a -2.6, up to and including a +3.